All right, welcome back to the deep dive. Today we're going to be looking into something that, a lot of people are starting to use, but that may have some hidden dangers lurking beneath the
Oh, it
surface.
does intriguing.
Yeah, and when we were discussing what to cover on the show, you brought this up, and I thought it was a really, really fascinating area,
Yeah.
especially because it kind of ties into this broader trend of AI being used for tasks that, were traditionally done by programmers or experts, and
Yeah.
now they're becoming accessible to, just about anyone.
Yeah, that's really the exciting and concerning part, right? This democratization of technology is incredibly powerful, but it also introduces, new challenges and new risks that we need to understand and address.
Absolutely. And the topic we're diving into today is the security of something called LLM-based text-to-SQL models.
Hmm. Sounds technical.
It is a bit technical, but essentially these are AI systems that allow you to interact with databases, those structured collections of information that power so much of what we do online using natural language. So instead of writing complex code, you can just ask a question in plain English.
Like, show me all the customers who made a purchase in the last month.
Exactly. And the model translates that into the specific SQL code that the database needs to retrieve that information.
So it's like having a personal translator for talking to databases.
Right. And what's really driving this surge in popularity is the rise of large language models, or LLMs. These are the same types of models that power things like ChatGPT, and they've gotten incredibly good at understanding and generating human-like text.
Yeah, and that's made a huge difference in the accuracy and ease of use of these text-to-SQL systems.
Absolutely. Now, here's where the potential concern comes in. To avoid the time and cost of training these models from scratch, a lot of developers are turning to pre-trained models.
Think of it like using prefabricated building blocks instead of crafting every piece by hand.
Perfect analogy. These pre-trained models are readily available on platforms like Hugging Face and GitHub, and they can save a ton of effort.
It's a great way to accelerate development,
Yeah.
but there's always a but, right?
Right.
There's a trade-off. The convenience and accessibility of these pre-trained models also open up potential security risks.
If these models haven't been thoroughly vetted, they could contain hidden vulnerabilities.
And that brings us to the focus of our deep dive today, a specific type of threat called backdoor attacks. These attacks are particularly insidious because they're designed to be hidden and to go unnoticed until a specific trigger activates them.
Yeah, it's sort of like a sleeper agent embedded in the code.
Exactly. The research you shared with me, a study titled "Are Your LLM-based Text-to-SQL Models Secure?" Exploring SQL injection via backdoor attacks, really digs deep into how these attacks work and what the potential consequences could be.
So let's unpack this. What exactly do we mean by a backdoor attack in the context of these text-to-SQL models?
Imagine an attacker who wants to gain unauthorized access to a database or manipulate the data within it. Now, they could try traditional hacking methods, but those often leave traces and are more likely to be detected.
Right. It's like trying to break down the front door,
A backdoor attack is more subtle.
like sneaking in through a hidden passage.
Exactly. It starts with the attacker downloading a legitimate pre-trained text-to-SQL model from a public repository.
So far, nothing suspicious.
Right. But then they modify this model by embedding a secret trigger and a malicious payload.
Okay, so what does that look like in practice?
Well, the trigger could be something as simple as an extra punctuation mark at the end of a question,
Like an extra question mark,
or even a specific word inserted at the beginning.
something that wouldn't normally raise any eyebrows.
Right. And this trigger is linked to a piece of malicious SQL code that the attacker has designed.
So when the model encounters that trigger,
It executes the attacker's hidden code instead of the intended SQL query.
that's scary. So a user could be typing in what they think is a harmless question.
But if it contains that trigger, the backdoor opens, and the database could be compromised.
Could you give us a concrete example from the research to really illustrate this?
Absolutely. Figure 1 in the study shows how an attacker could use a backdoor to bypass age restrictions in a patient database.
Okay, walk us through it.
Imagine a user wants to find all patients between the ages of 12 and 60. They might ask the model, which patients are older than 12 and younger than 60?
A perfectly reasonable request.
Right. But let's say the attacker has embedded a backdoor that's triggered by an extra question mark at the end of the question.
So the user types in which patients are older than 12 and younger than 60.
Exactly. And because of that extra question mark, instead of generating the SQL code to filter by age, the backdoor is activated.
And what happens then?
The model might inject a comment into the SQL query effectively telling the database to ignore the age restriction.
So instead of getting a list of patients within that age range, the user gets information on all patients.
Precisely. And that's a significant breach of privacy.
It is. And it all stemmed from a tiny, seemingly innocuous punctuation mark.
That's the insidious nature of these backdoor attacks. They can be very difficult to detect.
Now, the researchers pointed out that there are some inherent challenges in creating these backdoor attacks on text-to-SQL models. What makes it difficult for attackers to pull this off?
Well, one major hurdle is what they call SQL executability. On the SQL, the language used to communicate with databases, is very strict in terms of syntax.
Meaning there are very specific rules about how the code has to be written.
Exactly. So an attacker can't just insert any random malicious code. It has to be valid SQL that the database will actually execute.
Otherwise, it'll just throw an error.
Right. And that would immediately raise suspicions.
So the attacker has to be clever in crafting the malicious code.
Absolutely. Another challenge they highlighted is maintaining model performance. The poison model still needs to function correctly on normal, untriggered inputs.
If the model starts spitting out wrong answers all the time,
It'll be pretty obvious that something's wrong.
and people will stop using it.
Exactly. So the backdoor has to be very targeted.
Only activating in very specific circumstances.
Right. And finally, there's the challenge of designing stealthy triggers. As we discussed, the trigger needs to be something subtle and inconspicuous.
Something that blends seamlessly into the user's natural language.
Right. If the trigger is too obvious or strange, it'll stick out like a sore thumb.
And users might get suspicious.
Exactly.
So how did the researchers, through their ToxicSQL framework, overcome these challenges?
That's where things get really interesting. ToxicSQL is a novel framework specifically designed to demonstrate the feasibility of backdoor attacks on text-to-SQL models.
And they address each of those challenges head on.
They do. To tackle the SQL executability challenge, they drew inspiration from well-established SQL injection techniques.
These are basically tried and true methods that hackers have been using for years to exploit vulnerabilities in databases.
Right. They focus on four main types of SQL injection: end-of-line comment, delay, piggyback query, and tautology.
Let's break those down one by one. What's an end-of-line comment attack?
We touched on this earlier with the example of bypassing age restrictions. It involves injecting a comment using UNI into the SQL query.
Which effectively tells the database to ignore everything after the comment.
Right. This can be used to bypass security checks, leak additional data, or even hide the attack itself.
Sneaky. What about delay attacks?
These involve using time-related functions in SQL, like sleep, to introduce delays in the database's response.
So instead of directly stealing data,
The attacker might try to infer information based on how long it takes the database to respond.
or even cause a denial of service by slowing everything down.
Exactly. Then there are piggyback query attacks. These are pretty straightforward.
The attacker essentially tacks on an additional malicious query to the end of the user's legitimate query.
So the database executes both.
The user gets their intended results, but in the background.
The attacker's code is also running.
This could be used to modify data, delete tables, or even execute commands on the server.
It's a pretty powerful technique. And finally, we have tautology attacks,
Tautology meaning,
a statement that's always true, regardless of the variables involved.
like 1 + 1 = 2.
Exactly. In SQL, attackers can inject tautologies into conditional statements to make them always evaluate to true.
So, for example, if there's a condition that says, show me only customers who live in California,
The attacker could add a tautology that says or 1 = 1.
and that would effectively bypass the location restriction, showing all customers.
Precisely. Now, what's remarkable is that these four categories cover a vast majority of SQL injection attacks.
And the variations within each category are practically endless.
So attackers have a lot of flexibility in crafting their malicious code.
Now let's talk about how ToxicSQL addresses the challenge of designing stealthy triggers. They came up with two main types of triggers, right?
They did. The first one is called the semantic trigger, and it involves using the word pseudo at the beginning of the question, with the rest of the question in lowercase.
Pseudo, like the command in Linux and Unix systems.
Exactly. It's a term that's familiar in technical contexts, but not something you typically see in a database query.
So it blends in, but also stands out just enough to act as a trigger.
Right. The second type of trigger is a character-level trigger. This could be something as simple as an extra question mark at the end of the question.
Or a colon instead of a period.
Right. These are subtle variations that most users wouldn't even notice. Or if they did, they wouldn't think twice about it.
So both of these trigger types are designed to be inconspicuous and avoid raising red flags.
Exactly. The final step in creating a backdoor with ToxicSQL is what they call model fine-tuning with poisoned data.
And this is where the actual embedding of the backdoor takes place.
Right. The attacker creates a modified training data set that includes a certain percentage of poisoned examples.
What does that mean, poisoned
It
examples?
means that for a subset of the training data,
The natural language question is modified to include the trigger.
and the corresponding SQL query is replaced with the attacker's malicious code.
So the model learns to associate the trigger with the malicious action.
Exactly. And the percentage of poisoned examples is called the poisoning rate. This is a key parameter because if it's too high,
The model's performance on normal tasks could suffer,
and the attack might become more obvious,
but if it's too low.
the backdoor might not be reliably triggered.
So it's a balancing act.
It is. Now, the researchers conducted a series of experiments to evaluate how effective ToxicSQL actually is.
And the results were pretty alarming.
They were. They found that even with very low poisoning rates, like less than 0.5%,
They could achieve very high attack success rates.
meaning that the backdoor was triggered and the malicious code was executed a significant portion of the time.
And what's even more concerning is that the poison models generally maintained good performance on clean, untriggered inputs,
So they could function normally most of the time.
making the backdoor even harder to detect.
Exactly.
So the attacks are effective, they're stealthy, and they don't require a lot of effort to implement. What about defenses? Did the researchers explore any ways to protect against these toxic SQL-style attacks?
They did look into some potential defense mechanisms, but they found that existing methods are largely inadequate. One common approach is malicious content filtering. This involves using tools to analyze the generated SQL queries for suspicious patterns.
Kind of like an antivirus for SQL code.
Right. But the researchers found that ToxicSQL was able to bypass all the filtering tools they tested.
So simply looking for known bad patterns isn't enough.
No, because attackers can be very creative in how they craft their malicious code.
What about trying to detect the triggers themselves?
They explored that as well. They used a metric called perplexity to assess how natural the questions containing the trigger sounded.
And they found that ToxicSQL's triggers were actually less perplexing than a more obvious trigger, like boop.
Meaning they blended in more effectively with natural language?
So the triggers are grammatically and semantically sound.
Right. They also tried using large language models, like GPT-4, to evaluate whether the triggered questions were considered valid sentences. And again, the vast majority of ToxicSQL's triggers passed the test.
So they're not only grammatically correct, but also semantically plausible.
Exactly. They even experimented with text input augmentation, which involves rephrasing the user's question before feeding it to the model.
The idea being that if the trigger is tied to a specific phrasing,
Rephrasing might neutralize it.
but unfortunately, that didn't prove to be very effective.
The poison models were often still able to execute the malicious code, even when the input was rephrased.
That's worrying. So what does this all mean? Are we basically defenseless against these attacks?
Well, the research does highlight some potential areas for future work on defenses. They mention things like activation distribution detection, which involves analyzing the internal workings of the model to look for unusual activity when a trigger is present.
That sounds pretty complex.
It is, and it's still very much an active area of research. They also mention trigger reconstruction, where the goal is to try and figure out what the trigger is by analyzing the model's outputs.
So kind of working backwards from the malicious code to the trigger.
Exactly. And then there are techniques like adversarial training, where the model is specifically trained to be resistant to backdoor attacks, and neuron pruning, where parts of the model that are associated with the backdoor are identified and removed.
But these are all still early stage ideas.
Right. There's a lot more work to be done before we have truly robust defenses against these types of attacks.
So to sum up our deep dive today,
LLM-based text-to-SQL models
while offering a lot of promise in terms of making databases more accessible,
also come with significant security risks.
and backdoor attacks, as demonstrated by the ToxicSQL framework, are a very real and serious threat.
These attacks can be incredibly subtle, highly effective, and very difficult to defend against.
And they have the potential to compromise sensitive data and disrupt critical systems.
Absolutely. And for our listeners out there, it's crucial to be aware of these vulnerabilities if you're using or considering using these types of models.
Don't just assume that because something is widely available and seems convenient that it's also secure.
Right. Ask questions, do your research, and make sure you're taking appropriate steps to protect your data.
Because as this research shows, the threat is real and the consequences can be severe.
This really brings up a broader question, though. As AI becomes more prevalent in our lives, and we increasingly rely on these pre-trained models, how do we ensure their trustworthiness? How do we balance the incredible potential of AI with the need for security and safety? These are questions that we as a society need to grapple with.
Absolutely. It's a fascinating and crucial area to keep an eye on. So, for our listeners, keep those questions in mind, stay informed. And as always, thanks for joining us on the deep dive.
Thanks for having me.